You're listening to ChainLeak, the crypto news podcast with your host, Joshuwa Roomsburg. Follow and subscribe today.
Welcome to the ChainLeak Podcast. I'm your host, Joshuwa Roomsburg. Today's episode is about Layer 2 Scalability, Rollux. Today's episode is brought to you by Rollux, a Layer 2 solution powered by Syscoin. Today's guests, Jag and Alex from the Syscoin team. Welcome to the show.
What's going on, Josh? Thanks for the invite, man.
Thanks for having us again.
All right, so first, give us an introduction to Rollux.
So Rollux is our layer 2 solution, which is pretty much one of the final stacks in Syscoin's blockchain. As you know, or as we've been preaching throughout all this time, modular design is the way to go. And we have our layer 1 blockchain of Syscoin that's secured by Bitcoin through merge mining. And now we have the layer 2 where all the scalability is going to happen. So we're just really excited for having essentially the most performant blockchain in history. We're expecting, the lowest transaction fees, the highest performance, the bestest model with data availability. So we're excited to talk about it today.
Okay, now Jag, this is your baby. I need you to put some input on that.
The turtle wins the race. That's basically what we've been doing, is slowly and surely kind of researching what works, what doesn't work, and employing a Bitcoin mentality first design philosophy. Like, we focus on decentralization and security over convenience and speed at the base layer. And, we haven't had that traction up to date because users are not expected to use a slow, fully decentralized system where the costs will go up if they're using that. And finally, through realizing these things and developing the support services in the blockchain to scale these things up, we've gotten to the point where we're finally able to extend the modularity of the blockchain and have that full functionality where the users will be using it almost like doing day-to-day Visa, MasterCard type of use case transactions and DeFi in a way where you're abstracting the costs off as much as possible and still retaining that security like you would be on like Bitcoin itself.
Let me feed on that. You're saying Visa and MasterCard type transactions. What do you feel is the cost per transaction, or would it be when this launches?
Yeah, what you have to think about there is the quality of the transaction. And, in Visa, MasterCard, the quality is quite low because there's chargebacks and a whole bunch of issues. It's just basically going through a bunch of servers and giving a ping back that it was received. That's how it's coming to consensus through centralized servers. But obviously, if those servers are confiscated or the company decides they want to not honor them, or if there's a chargeback, then you can always take those things back. And the quality of some blockchains that are trying to scale on one layer, quality is also low because it may seem like you're getting high throughput until a lot of people try to join that system, or there's a small number of validators that are securing that system. And so it's almost like a Visa, MasterCard quality level where some small number of nodes get taken over, and then all of a sudden your system is kaput because, you could do a couple of thousand transactions a second and prove that out and run as fast as Visa, MasterCard until the average Joe tries it out and everyone's using this and it breaks down because either the fees have to go up there, system breaks down, or the incentive to attack gets much stronger and people start to attack that middleware, which is the validator system.
How do you feel you emphasize the quality of transactions on Rollux? What do you feel are the focal points there that sets Rollux apart?
Yeah, it's first principles of decentralization and security. Like, you have to think under a situation where there's a war, or there's a situation where things just aren't working, or the internet's not dependable, even in a situation where there's inflation, in a situation where there potentially the cloud servers are going up and down. You have to think that is what the things that can punch through those, the things that can work across those, are the dependable services that really will be the difference, because now those aren't as hackable. Those aren't as what in the technical side you'd call that the Nakamoto coefficient. It's how resilient your system is to disruption, how many different types of nodes you have to attack, how many things you have to get rid of for that system to break down. And the problem is that there's always been a trade-off. Like, as you become more decentralized, the slower things get. And so the realization of, in a modular blockchain, we could you technically only need to run one server, which is what we're starting with. It's not, the sequencing doesn't need to be decentralized, but the where you put the data needs to be decentralized. At least where you prove that the data of your transactions exist. When the blockchain is confirming this on the first step, needs to be as decentralized as possible. And through these realizations, we've offloaded a lot of the work on the base layer, and we've started to put it on this single sequencer, which can scale up obviously much quicker than even any of the blockchains with even 10 validators could scale up, right? And now you've scaled up, but your quality is much higher because that disruption cannot happen at that base layer. That disruption,
it can't shut down.
Yeah, I mean, you could shut down that single sequencer, but all of your funds are still safe, because you could always move back to the base layer or move to another system that's not shut down on layer 2, and none of the money's lost, right? It's a liveness concern, it's a convenience concern to be able to have that single sequencer shut down. And even those secondary layers are going to be decentralized as well through validators or proof of work or ZK miners that are going to come along and do that as a service. So thinking about it the right way is the way to go, but scaling up with responsibility and decentralization in mind was the hard part, and that's what we've figured out with our design.
Speaking of building Rollux out, let's get into who is the team behind Rollux.
Yeah, Sys Labs, the guys behind the foundation. Now that we have sort of infrastructure, we're productizing, what are the unicorn stacks of softwares that need to run on top to take advantage of such a software suite, decentralized security. And there's a few big things happening in the space in fintech in general. There's digital tokenization of everything around us.
Right.
Physical real world assets being tokenized that requires compliance. So there's a big push towards compliant assets and how to deal with that in the public DeFi realm. There is super apps and convenience. How do you get your parents to use this system without requiring, crazy passwords? The thing is, in the digital world, passwords are going to become more and more susceptible. And yeah, a passwordless solution needs to be figured out. And
right,
then,
especially with the quantum computers coming.
Yeah. So yeah, I mean, Alex maybe can jump in on some of them as well.
Yeah, I kind of want to put into layman terms what Jag's been talking about as far as how the whole system works, so people just really understand it. What we're talking about here is a layer 2 solution. When you build, you have to build with either, and I know those will be big words for some people. There's the monolithic and then there's modular. So let's break it down. Monolithic is when they try to do everything all in one place. I used this illustration the other day. Let's think about a mall, right? When you think about like the biggest malls in the world, you think the Dubai Mall. That's not just like one big stretch of land with the mall where you're walking across it. You have, your parking lot, you have your first floor, second floor, third floor. And it's just built in layers, right? It's the same way when considering blockchain. You want to have a really good infrastructure, a good system. So the way these rollups work, these layer 2s, are where you will actually be able to kind of package all those transactions. Like if you had a shipping container and you're shipping it all down to the layer 1. So it's really, in a sense, kind of like the layer 1 or the layer 2 is inheriting the security of the layer 1. So that's how we're able to kind of put all of this together. And it's exciting to see kind of the team putting together. a lot of us working for the foundation itself, establishing Sys Labs, not only creating Rollux, but a whole bunch of unicorn products that are going to be built on Rollux.
That was another thing I was going to ask you next is when you speak about the same team building out Rollux, are you guys all building out the dApps on top as well? Or do you have individual teams that are working on certain aspects?
Yeah, so we definitely have an extensive team with different people working on different things. So even though it's kind of like we have this one cohesive unit, but then we've got partners that we work with and that frequently are assisting us with different types of products. Jag is usually the humble guy, but he's the big brain behind of a lot of the stuff that we do. And we just go forth. Everyone does their job and execute. And it's been very efficient. You know, we definitely always are learning when a lot of us are working remote, but it's been a beautiful process working with the guys and just getting to the point where we are now.
Okay. Now, a big factor with Rollux is having the security of Bitcoin, but the scalability of an EVM. Would either of you like to dive in on that? What was the that's it. What was that moment for you, Jag, when you said this is what I need to build out next?
It's a really funny process, been kind of iterative, but we've had this realization that the blockchain is a court system. It's not a Visa MasterCard processor, but you need to build these up in the layers. But how to do that was a big question until we started to see like rollups and Plasma and ZK start to come out. And we've been iteratively building up. And it's been very interesting that everything we've done, none of it has been rolled back. Most of it's just been building up on top. And every step we've taken, there's been probably 15 forks in the road for us. And we've always chosen the right one. So the casino craps, we've been very, very lucky in that. It's been very, very funny, and maybe it's meant to be like it was always going to be like that. So in terms of how, like, you basically start with like, so first of all, like there's been a big narrative on L2 on Bitcoin. Yeah. And my thesis is this is the closest you're going to get to an L2 on Bitcoin, because you don't have the data availability and you don't have the token model that you need to build. A lot of the people on Twitter are talking about now that the L2s without a token, they simply won't work. There is no safety net that allows this L2 to work with decentralized sequencing, for example. You need some sort of economics aside from Bitcoin on top to make this work. So if you're already thinking about tokenizing, then you have to think, okay, that token cannot be parasitic to Bitcoin, because what if that token is deflationary only as well? Now you have a situation where that token is starting to take value out of Bitcoin. You know, now Bitcoin is not
on its own, right?
Yeah, and that secondary network is the thing of value, because that's where all the commerce is happening, right?
Right.
So then you have to avoid parasitic behavior. So you really only left with one solution, which is merge mining. If you're creating a layer 2 with tokenomics, that's the definition of merge mining off of Bitcoin. You're creating a side chain where you're borrowing just the security of Bitcoin through mining. You're not borrowing the blockchain itself of Bitcoin, like the blocks and the consensus on the blocks. You're only borrowing the fact that the miners are there providing all this hash rate, the physical transformation of real world into digital world, and putting that into the proof of work protocol is the value of Bitcoin, right? And we're tapping into that to also say you can solve more blocks than just Bitcoin at the same time. You can solve Syscoin. So that's the first step. Okay. And then the second step is, okay, now that we've got that security, we need flexibility. So do you build that into the Bitcoin model? Like they have this clunky stack system. You build like a virtual machine in there? No, you want to separate that. So you just run an EVM beside that. And you just make sure that everything that happens in the blockchain is one-to-one. Every EVM block and UTXO block is kind of combined. So you have a separation of concerns, right? That now you can't have a virtual machine break down that stack system. You can't have a stack system that breaks down the virtual machine. They're completely separate, well-tested. You want to touch on that?
I definitely want to touch on that. And I want to kind of bring it back to the whole design, because and how we need to shift our mind, how we need to shift this narrative of how blockchain actually works. Because the problem is that when people think the Bitcoin white paper, what does it say there? A peer-to-peer electronic cash system. And yeah, that's true. But we've already seen over the last 10 years that Bitcoin itself isn't meant to scale in that way. It's supposed to be that security layer, that digital gold. That's exactly what it's become, right? A store of value. So
Yeah.
now all these things that Jag is saying as far as design and how we need to get it done is the way to actually make it happen. Because we've got security on one side, and we're, like you say, we're borrowing that security in our chain. And then on the other side, you've got Ethereum, which is introduced the concept of programmable money, and a huge use case, right? With NFTs, smart contracts, all that stuff. So we're implementing that as well. So if people can think of a layer one being a court system instead of it being, oh, we need to transact as much as we can, then they're going to see that a modular design is the way to go. And that's actually a lot more functional.
As you guys are building this out and you look at other layer 2 solutions and the challenges and disadvantages that they have when they build out, have you guys taken into account what anybody else is putting on the market and creating alternative options for their downfalls? Without naming any specific names, but have you looked across the market and seen what else is out there?
Well, yeah, definitely. I'll let Jag speak to this in a second, but he's always doing research on all these layer 2 solutions. He was one of the first to realize how important ZK is going to play a role. And we're cool with a lot of these roll-ups. You know, we have relationships with them. You know, Rollux is a fork of Optimism Bedrock. But I think the importance goes, the importance should be stressed on the layer 1 solution. The way that was designed, the way Syscoin, the Syscoin layer 1 blockchain was designed, enables us to have an efficient layer 2, because we've got the proof of data availability, we got the spaced out block times for the network not to boggle on the layer 2. So we never have to really, we're kind of future proof in that sense. So that's where I say where the true advantage lies. And then all of the future development that will be happening on layer 2s, I'll let Jag speak to that, because there's incredible amount of technology that we're going to be able to take advantage, like ZK and other stuff.
Okay.
So that when you're getting into that world, the layer 2s, because you're breaking down the blockchain. The concept of blockchain has two parts. There is the settlement, or the events that are happening at the court system level, like the large scale events and the organization of blocks, the order of events and the settlement of them. And anything that happens that cannot happen in another order once it happens, has to stay like that, unless it reorganizes within a short period of time, right? And finality with Ethereum and finality in other blockchains prevents you to roll back in a large history as well. So that's important. I'll talk about why, but that's one part of it. And the second part of it is to have enough data to be able to replay these events in that same order from someone else to prove that you are correct in the history of what the system is. So when I sync up to you, or when I download the blockchain to prove that it is what it is, it's a safe system that has the database of value is all correct. You have to have the data, and you have to have the algorithm or consensus that the ordering has happened properly. So you're shifting that to layer 2, which means you're creating a bridge, and that bridge is built into the smart contract layer right onto the base EVM. So in this case, Syscoin. That bridge is responsible for ordering of events. And if things happen like on the blockchain, they shift back a couple of blocks, the bridge is dealing with that, right? Because you're settling on the base chain.
Right.
So that's kind of the realization that the bridge is basically just an event queue where you can deposit into it and you get your value on the secondary layer, and then you can withdraw from it in a trustless way and get value out. Now the trick is, if you're depositing value, that's fine, but when you're withdrawing, how do you if it's just a bridge and there's no way to prove who you are, what you are, you need a way for the data, the data component to be there as part of that blockchain. So since layer 2 is a blockchain, where do you put the data part to be able to prove to the world that you own some value into it? Like in Bitcoin, it's all part of the block system, right? In layer 2, there are no blocks inside of the main chain. It's just a state. Here is the latest state, but there's really no blocks. So you separate the data component, and what Ethereum rollups and what some of these rollups are doing today is they're putting all of the data back into the base chain, and that's effectively creating like a pseudo block. But by doing that, you're moving all of that data back into the base chain, and that's there forever. And the bottleneck then is how much data you're throwing at it. So if you're having 500 transactions a second, your fees on the base layer go up because you're storing all this data back. And even though it's not processing it, it's still storing, and that's adding a lot of cost. So to alleviate that, you can separate the data part of it. So your bridge actually is just the reorganization queue and making sure order of events is properly, and the data component could be kind of moved off to this special layer that stores it for a short amount of time and then just deleting it after that. And that's what's happening in Ethereum with something called proto-danksharding coming up. It's going to be the next release, but it's like a sidecar of data that the rollups use, but fully decentralized, meaning the bridge actually gets a confirmation that the data through its hash was actually settled. It's official. And so you can't lie that data didn't exist. And the data is stored, but it's removed. And therefore, it's not invoking the cost of the court. It's not long-term cost. If someone's downloading Ethereum or Syscoin, they will not have to download the data of all the layer 2 transactions. They just get a simple hash, and it's very, very efficient. So that in order to do the data pruning, deleting stuff off the blockchain, then you need a concept of finality. And that means you cannot move back past some point on the blockchain. After 5 blocks on Syscoin, they get hardened and you cannot move back. So after 5 blocks, we can start to delete things. Because if you can roll back and the data has been removed, now your blockchain can't progress anymore from that point, right? So we've solved the problem of finality through masternodes, and they vote on the blockchain, but we don't relegate ourselves down to proof of stake, because the Bitcoin miners have the ultimate say, and all these masternodes, all they're doing is saying, hey, look, I see the blockchain at this state. Let's all vote on it. If we all vote and we all agree, then that is the state 5 blocks back. And so you have 5 blocks to reorganize as a miner and try to screw around. Usually asynchronous processes happen anyways, and many miners don't agree. They're all fighting each other, right? But you have that 5 block kind of discrepancy. But after that 5 blocks, it gets hard, and you cannot roll back from that point. So from that point, we could start to prune data. And from pruning, we create our own data availability service on the base layer. What some of these other rollups are doing is, because this service doesn't exist on Ethereum, they're storing their data off-chain, and they're creating new consensus systems to secure your data. They still have the bridge to secure the organization and the state, like the first part of it, but the data part, they're throwing it off. And so you don't get that same security. And they're saying, let's
you're saying they're taking that data off-chain?
Right, and so they create new committees, new consensus systems, new proof of stake.
Outside of the main chain.
Right, and that creates a new trust. It creates a new trust factor.
It's adding more complexity.
Well, not only complexity, but you have to trust now not just Ethereum or the base chain. We have to trust another system. So if that other system doesn't have the same Nakamoto coefficient, now it's not as secure, decentralized than just using the base.
Then you could have potential problems on the original chain. Right. Start a whole nother mess.
Improving now, that data, yeah.
Alex, could you break down data availability and how it helps with scaling?
Yeah, I think Jag did a real good job, but all I'm going to do is simply kind of condense it down and give a nice illustration. So the end result of data availability for you users out there who want to know, like, well, what's the benefit of this whole data availability thing? It doesn't boggle down the network, and you're always secure to exit off the layer 2, meaning that fees are going to stay low permanently, you could say. So how does it work? Jag explained it, but we see layer 1 as that court system, right? So let's pretend Josh, Jag, me, and there's 9 other jurors, right? And they bring into the court case this evidence. That's the data. So we each got a copy of the evidence. I show you my evidence. Josh, you show me yours. Jag shows me. He's like, all right, this is all the same evidence, right? Okay, yeah, we all agree on that. Boom. That's the hash in the system that we put into Stamp. Now we don't need all these copies of data, because when a lawyer comes and does some research because he needs to prove what happened in this case, he's not going to need to see all our pieces of data. He just needs to know that we all agreed that, hey, this was the data. So that's where the
Yeah.
pruning of the data comes in. And we have a
You
process.
don't need 11 copies of the same information, right?
Exactly.
Like we're storing that data on Filecoin, we're storing it on Cloudflare R2 and a bunch of other services. So at least as long as one copy exists and people have access to it, enterprises can download and keep it secure on their own. A layer 2 service provider can do that, but it's separation concerns. The layer 1 merge miners like F2 Pool has no awareness, doesn't care, shouldn't be affected. It doesn't know or care what you're doing on layer 2. It's completely isolated and asynchronous. And so the layer 2s can manage their own state and their own providers and their own data, but it's still secured through that same decentralized process. And I wouldn't say it permanently solves scaling to the moon or infinitely. This is, again, like just like when the internet was created, it created a cyclical, a flywheel effect of innovation, but it still required people to get involved and do it. It wasn't infinite. There are server costs and stuff. So you do have still the same, you're going to scale well past the Visa MasterCard level of scale, but you're not going to be able to do an infinite number of scaling. If someone says you can infinitely scale, they're lying to you. At some point, there's going to be a server cost, there's going to be computational cost, right? And the fees are going to go up. We still have to consider what Rollux is a base layer. It's a base layer for consensus. It's still a single node, but still that data is happening on Syscoin and it's secured through Bitcoin. And anything on Ethereum is doing, it's still secured through a consensus, right? So at some point, whether that be 10,000 or 50,000 transactions a second, the fees will go up. You still have to think that at some point, but if you're hitting 5,000 TPS and above, you've already got global adoption. You're already at Visa MasterCard level of scale. So if we can serve 5,000 or 10,000 TPS at sub-second, at sub penny, that is good enough to serve as a global base layer for settlement. And then you still have to innovate past that for custom executions and you're running a TradFi engine, you're running a GameFi, you run a metaverse. It could be spawned off of the layer 2 into a layer 3. You still have to consider that you might want in isolated circumstances to store the data off chain. You still might want that because that's the bottleneck in all of the blockchains is going to be where that data is.
Now, you just spoke about the metaverse. Let's go into how Rollux will implement smart contracts. What types of things can you guys see Rollux being used when it comes to smart contracts?
I think we could say generally everything that we're seeing being used today. I mean, it's
so like Ethereum. NFTs, games, in-game assets, ownership of real world assets, all them types of things.
Yeah, absolutely. It's going to be just like deploying on Ethereum. You'll be able to deploy all these things on Syscoin the same exact way. And what's really nice is there's a lot more, performance EIPs that are being established. So technology is getting out there. Like right now we have EIP for account abstraction, which essentially will be able to help you. I'm drawing a blank here, Jag. Help me out.
It'd be like having a bank account, but owning your own bank account. Like you have separate accounts for different uses. And it's going to be much more, again, grammar friendly and possibly password free biometrics and all this stuff. So it's the big push towards the industry right now, especially with AI coming and machine learning and detecting who you are, is going to be proof of person. So first, in order to create a crypto account, you're going to have to prove to the blockchain that you are a person, not a bot, because the value of a person will be much more than a value of a bot, and services will want to detect that as well. So proof of person is going to be your first entry point from your physical person into your digital person. And from there, you're going to be looking at how to do passwordless authentication with account abstraction. So you have your not burner wallet, but you have your trading account, for example, and that trading account could be tied to your email address that you're using for everyday transactions, but you're not storing all of your money there, and all of your money could be in a separate account. But it's isolated. It's in the account abstraction wallet. You have your cold storage, which is a separate authentication, which requires a password. It requires a YubiKey or some sort of hardware wallet, and it requires biometric as well, right? And then the trading wallet might require your biometrics plus a PIN code or something like that. So you can make these distinctions and do this in a separate way. But it all starts with, first you have to prove you're a person. That's what WorldCoin is trying to do.
Okay.
But we're extending beyond that. We're saying we can do better than that. The proof of person is great. The biometrics is great to make things password free. Then you can tie things to zero knowledge to your email account and to other ways so that you can create separate accounts that are still password free. They're tying to your email address, for example. That's the most common form of digital identity is email.
Yeah.
And you can still have that same security. That's kind of where the usability is going to come on. And it's tying to all the smart contracts. So any smart contract you're interacting with, your point of infliction is going to be a physical person trying to do something in the digital world. He has to say his intent and he has to sign on his intent. It has to be his money. It can't go through a third party. It has to be direct with the blockchain.
Now, you're talking deep about what Rolex is going to be building out. As far as wallets go, what type of wallet does an end user need to access this new network?
Well, you can use MetaMask and you can use all the traditional wallets, but we're going to one up that. Poly is our Chrome extension.
Okay.
And one of the things about MetaMask is they've made it specifically for Ethereum with Ethereum block times and layer 1, right? But it has a timer in there. Every 20 seconds it's going to check for confirmation. It's not very user friendly for fast confirmations or layer 2s in general. So we developed Poly, which is the Chrome extension, and also the Poly mobile wallet, which is catered to layer 2 and any layer 2s, like on any of these blockchains, because that timer will be more WebSocket based and it'll be able to perform sub-second confirmations with the
that's
blockchain.
cool.
So on Poly plus Rollux, you'll be able to see 2 to 4 second turnaround times of a check mark versus 20 seconds or more on MetaMask. So that's one thing. And then the second thing is Poly is meant for more of the crypto native folks. So if people are using DeFi and expecting, feedback right away and doing staking and all that stuff, there's Poly wallet, right? That's the mobile extension, the mobile wallet, the Chrome extension, the mobile wallet. And then there's SuperDApp for the average Joe, the moms and pops. Maybe this whole biometric thing will start there. There's an AI component to that to learn your tendencies or help you solve problems, help you solve day-to-day life, make things easier, do business processes or whatever you want to do with AI. You have that it's like a super app with AI built in and Web3 that will be password free, potentially hook up to your email, have biometrics, and make it really easy for average people to start tinkering around with Web3.
Okay. Now, the next angle I'd like to tackle are the developers that could potentially build with Rollux. How do they go about building out? How do they get involved? And then from a developer aspect, what is the pricing and availability for building over here versus on an Ethereum layer 2?
Go ahead. I was just going to say there's an op stack that we're using Bedrock, Optimism Bedrock, and it has a stack where developers can actually build their own blockchains if they want and feed that off of Rollux. So if a developer wants to go all the way and create a whole new ecosystem, he definitely could spin up like one-click type of launch his own blockchain and it's settled on Rollux. And it can tie into our data availability service, which we've already done the work to send general purpose messages from layer 1 to layer 2. So if you can send general purpose messages, we can also send the confirmation of the data to layer 2. And then the roll up on layer 3 can detect on layer 2 if the data is confirmed. So it's almost like a recursive loop of like a tree structure you can create where developers can create their own ecosystems. If you're just looking to create a DeFi protocol, you could launch that just like you launch on any of these EVM blockchains. So it's the mature tool sets are all going to work. You don't need to change anything. Those same DeFi contracts on Ethereum will port over, and we stay up to date with the latest Ethereum spec. So all the contracts will work. There's no change. We're running a Geth node natively. But in terms of the flexibility, it's really up to the developer. How deep do they want to go? Do they want to create their own ecosystem, or they want to tap into just a DeFi market? All of it's kind of separated from the base layer. They only need gas to settle on for data and for settling the organizations of events. But everything else, you can have your own token models and can do whatever you want. You can have your own DeFi, and first mover advantage probably applies there, because the first DeFi protocol to launch will get the most sort of interest from the community.
Yep. Now, Alex, to close out the interview, is there anything else you'd like to add that we haven't already discussed about Rollux?
Yeah, let's talk about the hyping points, right? What's going to get people excited? And I believe a lot of times it comes down to speed, and it comes down to performance, and it comes down to affordability, right? Everyone's complaining about the Ethereum fees, even fees in other blockchains, they're rising up. And one of the things that I keep saying over and over is like Rollux is going to be the most performant layer 2 blockchain by all of these metrics. And I would specifically like to mention in regards to low gas fees. And I think that's what's going to bring a whole bunch of users over here. One example, I've actually various examples. We're seeing transaction costs being a fraction of a Sys, which is a fraction of a fraction of a fraction of a fraction of a cent.
Right.
I can keep going and going. We did with one of our future partners, Galaxy. They have a system where they do, it's called an OAT. It's like an NFT on-chain campaigns they do, and they give OATs and people mint the NFTs. Well, they started branching out into different blockchains, and their gas fee to mint on, for example, Optimism, layer 2, similar to us, 8 cents to mint a transaction, which you don't say as much, but let's think about like scaling big things, right?
Yeah.
And then even which was the other one that was Avalanche, anywhere from like 1 to 3 cents. When we tested that same contract on Syscoin, it was a fraction of a fraction of a fraction of a fraction of a cent. So we're going to have some crazy advantages, and I believe that's going to be a key, because all this time, it's like we've been talking. So it's like we talk the talk, and now we're really going to walk the walk. So it's exciting to see where all this hard work is going to come together, and people are going to catch on. It may take a little bit of time, right? Because you're getting used to using a layer 2 and stuff like that. But as these developers start seeing, holy cow, these fees are cheap, I'm going to deploy my contracts on Rollux. And it's just going to be like a symbiotic thing of users and developers getting onto the system. And then us, at Syscoin are always here to provide support to those people that need it, especially those developers, because we want a thriving ecosystem.
Okay.
If you go as a developer, what I would say to that is, if it's too cheap, I can also spam this thing, right?
Yeah.
Now you can
we were talking about that the other day, Jag, remember?
Yeah, and if you can go ahead and spam it, and it'll stay as cheap as possible before the fees do inevitably go up because of VIP 1559. But it's fine, because remember, most of the cost to the layer 1 is just going to be the data availability service, right? The only thing that's put on the bridge is the state, which is very cheap. It's constant cost. If you do 1 million transactions or 1 billion transactions, it's still the same cost. The data availability is what is going to be invoking the cost of layer 1. And remember, after X hours, that data is just deleted. So there's only a short-term 6-hour cost to the network, and it's just a network propagation cost. It's just me as a node sending data to someone else, and no processing. It's just sending and receiving and sending and receiving and deleting after that. So the actual long-term cost of the network is almost negligible. So if you try to spam that, that's what we're saying is this is the best you can do in regards to all of the scaling paradigm. Because any other design will start to add cost as you get more and more spammers and more people pumping this thing. The costs start to add up on all the nodes. In our case, the only cost goes on one sequencer, which we can scale. We can scale that one computer to the moon like as much as we want, and the network cost is negligible.
Okay. Is there anything else you'd like to add, Alex?
Man, Jag said it as best as possible.
Right. I think we covered a lot of different areas. I want to congratulate you guys on the release and launch of Rollux. Congratulations on that.
Thanks, man.
Thank you.
Yeah, I appreciate you guys being here today. This has been Layer 2 Scalability, Rollux. Thank you for being here. Have a good day.